Right. Right. By the algorithm of division, we discussed the algorithm of division mean people when we divide a function here called as the dividend function, when it is divided by a divisor, here the answer we get is called as the quotient, and finally the thing here we get called as the remainder, right? Now this algorithm of division states a common relationship among these four. It is the dividend function. The dividend function is equal to divisor into quotient plus remainder. This is called as the algorithm of division. And furthermore, we notice the sum of the degrees of this divisor and the quotient. Sum of the degrees of divisor and quotient is equal to the degree of the dividend. Right? When we add the degrees of this quotient and divisor, that sum is equal to degree of the dividend function. And this remainder, its degree is always less than the degree of this divisor. We identified that result. Remember that sum of the degrees of divisor and the quotient is equal to degree of the dividend, and the degree of the remainder is always less than the degree of the divisor. Okay, right. Now I think we did one question, how to use this algorithm of division to divide a polynomial function by another polynomial function. Right. Now today, people, we are moving to remainder theorem. Right. Then today the first heading you can write as remainder theorem. Remainder theorem. Right. Now I'll explain what is this remainder theorem. When we divide, suppose a function say fx, I'll take a third degree polynomial function like this. This third degree polynomial function fx, that is our dividend. Now we divide by a first degree polynomial function. In the remainder theorem, people remember the dividend can be any degree, but this divisor should always be degree 1. It should be degree 1. For the first degree divisor only, the remainder theorem becomes true. The remainder theorem states, people, when we divide this way a polynomial function of any degree by a divisor of degree 1 like this. This is a first degree polynomial function. When we divide this way this fx, this function, third degree polynomial function, is the dividend. When we divide this way, you know the long division method we learned last week. This third degree polynomial function we divide by the x minus 1 first degree divisor. Then after dividing, finally we get here remainder, and here we get a quotient. The remainder theorem states the way of obtaining this remainder. The way of obtaining this remainder directly without using the long division method or algorithm of division. Right. That method is this. The divisor you have to equate to 0 and find the corresponding x value. Right, that x value we substitute in the function for every x. Our function is this, no? Fx is equal to x cube plus 2x squared minus x plus 2. Then this x value we obtained is 1. That x value 1, we have to substitute for every x on the right hand side, and we have to simplify that. When you substitute x equals 1, here also we have x, then for that x also we have to put 1. Then that becomes f1. Right hand side, every x when you replace by 1, this is what we get. Then you can simplify this. This is 1, this is 2, minus 1, 2. This and this you can cancel down. Here we get 4. This answer is the remainder finally we get when we divide this by this. Okay. So therefore, you have to very carefully understand when we learn this remainder theorem. This remainder theorem states when any polynomial function of any degree is divided by first degree polynomial function, there will be a remainder. The way of obtaining this remainder is explained by this remainder theorem. Then here the limitation is the divisor should always be degree 1. Then method of getting the remainder is, people, that divisor we have to equate to 0 and we have to find x value. That x value we have to substitute for every x in the given function, that means the dividend. Then when you simplify, we get a value like this. That is the, people, remainder when that given polynomial function is divided by the first degree polynomial function. Okay. Now actually we can really notice whether this is true by dividing this third degree polynomial function by this x minus 1. Okay. Let's divide that one just to check this. Right. It's really okay, but we'll just use the long division method to divide this. Here x cube, right, plus 2x squared minus 6 plus 2 should be divided by x minus 1. Okay, right. You know the way of dividing this polynomial function by this x minus 1. The highest power terms we first divide, that is this x cube we have divided by highest power term in the divisor, then we get x squared. This x squared we must write where here. Then by that written figure we have to multiply this whole divisor, and the answer should be written below this original dividend. Then what we get is x squared into x is x cube coming, x squared into minus 1 is minus x squared. Now what we do is, people, this one we have to subtract from this. Then x cube minus x cube will be 0. Here we get 2x squared minus x squared is 3x squared, and this minus 6 plus 2, this we get. Right. Okay. Now right now again this 3x squared we have divided by this 6 secondly. 3x squared we have divided by this x. Then we get x and x we can cancel down, we get 3x. Then that plus 3x we must write here. Then multiply this and this. 3x squared come in and minus 3x come in. Right. Now subtract this way. 3x squared we can cancel down. And here, people, we get 3x minus x is 2x plus 2. Right now, this minus this plus 3x minus x is 2x. Now finally, this 2x should be divided by this x. Okay, then we get there plus 2. Right here plus 2. Then by this 2, you have to multiply this whole divisor, it's 2x minus 2. Now once you subtract 2x and 2x 0, 2 minus minus 2 is 4. Here degree is 0. Then we don't divide furthermore. Then we have finished dividing this. Then this is the quotient, right? This is the remainder. As you noticed, the remainder is 4. This is what people, the remainder theorem. This is the remainder theorem, right? Okay. Now, right, people? Right, now people will write the remainder theorem. Then when we write the remainder theorem, this is how we write it. We take our dividend function as fx and we divide that by x minus a. Then the remainder, see here, f1, how do you get this one? Equating this x minus 1 to 0, the x value only we have put here. That f1 is this form. Like that, when I equate this x minus a to 0, x is a, that x equals a, when I put here, we get something as the answer. That is the remainder. So therefore, fa. So this is how we write using the symbols the remainder theorem, right? And then write down like this. Remainder theorem, another remainder theorem, write down like this. When the polynomial function fx, when the polynomial function fx is divided by x minus a. X minus a. The remainder is fa. Remainder is fa. The remainder is fa. Okay, skipping a line, people write down, putting a star mark. Fa is the value of the function fx when x equals a. When x equals a. When x equals a. Right. Now let's see how to prove this. The proof is important. Right, come to the proof, people. Proof. Proof is the right. This is how we prove this, people. Now we assume when fx is divided by x minus a, definitely the device is first degree, no? then the remainder should be 0 degree. 0 degree means a real number, right? 0 degree polynomial function means a real number. I am going to assume that remainders are, and this function I am going to assume as 5x, right? That we assume, right? Then we can write like this. Let 5x and capital R, let 5x and capital R be the quotient and remainder respectively. Now people, we can write by using algorithm of division. By using algorithm of division, we can establish the result, people. This dividend function fx, you can write as product of the divisor and the what? Quotient plus R. This is what the algorithm of division states. Okay. Now you know this equality is not an equation. This is not an equation. This says left hand side we have a polynomial function. It is equal to the right hand side polynomial function. Here we have two equal polynomial functions. You know, when two polynomial functions are equal, this equality says us at any value of x, the left hand side and right hand side polynomial functions are equal. So we can put any value for x in the left and right for x. I am going to put for x in the left and right simply put in x equals c. Then what do you get? fa, right hand side a minus c, 5a plus r. This r is a number, real number, no? 0 degree polynomial function is r. 0 degree means real number. It doesn't contain x. Therefore, when we put x equals c in the left and right, since r does not contain x, when you put a for every x, the r won't change. But here people, whatever the value of this 5a, since this is 0, this product will be 0, and in the left hand side we have fa, right hand side it is r, and then r equals fa. But r is the remainder, so therefore remainder is fa. Hence the remainder is fa. Hence the remainder is fa. And this is how people we prove the remainder theorem. Okay. Now we'll write one question like this. Write down this way one question. Find the remainder. Find the remainder when fx equals x cube plus 2x squared minus 6 plus 2 when fx equals x cubed plus 2x squared minus 6 plus 2 is divided by x minus 1. X minus 1 verify the result using another method. Verify the result using another method. The question is find the remainder when fx is divided by x minus 1. Verify the result using another method. Right now, first we use the remainder theorem. We divide by x minus 1. When we equate this x minus 1 to 0, we get x equals 1. This way. That x equals 1 we substitute for every x in the function. This way. And simplify. We get 4. Then the remainder is 4. Now, another method to verify these people, we use the log division method. Right? Use this log division method. Okay? And verify the result. Verify the result here. Okay, no, right. It's okay. Right. Okay, now we'll move to the next part. Right, now the result in remainder theorem is this. When a polynomial function of any degree is divided by x minus a we said the remainder is fa. Right. Okay. Here we get the function as our quotient 5x. Now the next thing, people, you know, when we divide 12 by 3, answer is 4, 3 into 4, 12, remainder is 0. This remainder is 0. And because of this remainder 0 only, we say 12 is divisible by 3. Therefore, 3 is a factor of 12. 3 is a factor of 12. So therefore, people, in a division, whether this divisor is a factor or not, is a factor of this dividend, can be easily checked by observing this remainder. If this remainder is 0, then definitely this divisor becomes a factor of this dividend. Okay. When the divisor is 0 only, sorry, remainder is 0 only, the divisor becomes a factor of the dividend function. Like that, people, if this remainder fa we found equals 0, if fa equals 0, then definitely this x minus a should be a factor of fx. Okay, should be a factor of this fx. If this remainder fa is 0, then definitely this x minus a should be a factor of fx. This is called as the converse of the factor theorem. Converse of the factor theorem, not the factor theorem. Converse of the factor theorem. Then how to start the converse of the factor theorem? When fx is divided by x minus a, remains fa according to the remainder theorem. If this fa is 0, then x minus a is the factor of fx. X minus a is the factor of fx. This is the converse of the factor theorem. Then people, what is the factor theorem? Then the factor theorem is if x minus a is already a factor of this fx, then this fa must be equal to 0. That's the factor theorem. Okay, so therefore we learn the next one, the factor theorem and its converse. Right. Write down the next subheading as factor theorem. Write down factor theorem. Write down. If x minus a is the factor of fx, if x minus a is a factor of fx, then fa equals 0. Fa is 0. Right. Next one, converse of the factor theorem, people. Converse of the factor theorem. If fa equals 0, then x minus a is a factor of fx. Right? Yeah. This factor theorem and its converse also, people, we can prove. Let's see how to prove that too. And it comes the proof. Come to the proof. First one, factor theorem. When we prove the factor theorem, people, we have to start from where? x minus a is a factor of fx. From that we have to start. Now you know 3 is a factor of 12, no? Then we can write 12 equals 3 into 4. Like that, when x minus a is a factor of fx, we should be able to write this fx as a product of x minus a and another function. Yeah. Since you can write x minus a is a factor of fx, we can write fx is equal to x minus a into 5x. That way we can write. What is this 5x? 5x is a polynomial function in x, where 5x is a polynomial function in x. Now here also we have two equal polynomial functions. Then we can put any value for x in the left and right. I'm going to put x equals a in the left and right. We get fa equals a minus a into 5a. You know, people, this a minus a, this is 0. Then whichever this 5a, this 0 into that is 0. Then fa equals 0. That means when x minus a is a factor of fx, fa is 0. Right. Second proof is people converse. Converse of factor theorem. Converse of factor theorem. Right, people, now converse of factor theorem, when we prove, we have to start here fa 0. Starting from fa equals 0, we have to prove x minus a is a factor of fx. Right? Yeah. Here you can very clearly understand fa equals 0. Take this as number 1. Right? Subject to this only, converse is proved. Now we assume when fx is divided by x minus a, the remainder is r and the quotient has a function 5x or hx, anything you like. Okay? Then write down like this. Write down, let 5x and r be the quotient and remainder we get when fx is divided by x minus a. They put people respectively. Let 5x and r be the quotient and remainder respectively. We get when fx is divided by x minus a. Okay. Now we can write by the algorithm of division. Now by the algorithm of division. We can write people like this, no? Fx function you can write x minus a into 5x plus r. Okay. I'm going to take this and people as star relation. Now here I am putting here x equals a. Now put in x equals a. We get here fa equals a minus a 5a plus r. This a minus a into 5a is 0. We get r on the right hand side, left hand side fa. F equals r mean people, r equals fa. But by number 1, fa is 0. This implies r equals 0 because f is 0 by 1. Okay, r is 0. This r is available in star. We can put for this r what people 0. Now by star. We can write what people fx equals x minus a into 5x plus 0. This gives us people fx equals x minus a into 5x. Then see the function fx you can write as a product of x minus a and another function 5x. It's like to write 12 is equal to 3 into 4. So therefore this 3 becomes a factor of 12 like that. X minus a, this says x minus a is a factor of fx. Understood? This says x minus a is a factor of fx. This is how people we prove the converse of the factor theorem. Okay, right. Now we'll come to the questions in the tutorial. Take question number 34 as the first question in the tut. Question number 34. Question number 34. Read question number 34. At question number 34, you are given fx ax cube plus 15x squared plus 6x minus b, where a and b are constants. X plus 1 is a factor of fx. if x plus 1 is a factor of fx, people, what function becomes 0? Yeah, if x plus 1 is a factor, here x minus 1 is a factor of fx. That is the result there we had. Now, if x plus 1 is already a factor of fx, then people, by equating this x plus 1 to 0, take x value, it's minus 1. Then that x value, when you put where here, we get f minus 1. No? That should be 0. That means when you put this x equals minus 1 on the right hand side, that is the meaning of this. The simplified answer should be equal to 0. Simplified answer should be equal to 0. Right? So then x plus 1 is a factor of fx, mean people, put in x equals minus 1, the resulting value should be equal to 0. Right? A minus 1 to the power 3 plus 15 minus 1 squared, 6 minus 1 minus b equals 0. Here we get minus a. Here we get 15 minus 6 minus b equals 0. 15 minus 6, you can take the right hand side, people. Minus 9 minus a minus b. Then multiply by minus sign, minus 1. We get a plus b equals 9. Number 1. What's the next data given? When fx is divided by x minus 1, the remainder is 16. Right. When fx is divided by x minus 1, when fx is divided by x minus 1, the remainder is 16. Remainder 16. People, according to remainder theorem, when fx is divided by x minus 1, the remainder can be written as f1. How do you get this one? Equate this x minus 1 to 0 and find x. That value only we have to put for this x. f1 should be equal to 16. f1 mean, people, in the function fx, for every x we have to put 1, then the answer is f1. Then we can write a times 1 cube plus 15 1 squared plus 6 into 1 minus b equals 16. And here we have a minus b, here 15, here 6. Take the right hand side. Right? Minus 5. (16 minus 21 is minus 5. This is number 2. Then by 1 and 2, you can take this b values. By 1 and 2, we get, and this 1 and 2, a is 2. Then by 1, b is 7. We get the answers like this. Now asking people, write down fx as the product of linear factors. Write down fx as the product of linear factors. Now what is our fx? Therefore, we can write fx, substituting for this a and this b. A is 2x cubed plus 15x squared plus 6x minus b 7. This is fx. I'm asking to write this fx, product of linear factors. Right now, one linear factor we know already. It is given in the question, x plus 1. Then I can write this fx okay. One linear factor we know, x plus 1. If this fx has another factors and if they are linear, then it should have another 2 linear factors. The reason is here this is degree 3. Then if this fx has only linear factors, this is degree 1, then another 2 linear factors we should have, then only here degree 1, here degree 1, degree 1, degree 1, degree 1, 1 plus 1 plus 1, we get 3 equal to the left hand side degree. Right? So therefore, we should find another 2 factors. That can be done in 2 ways, people. First is this. We guess values for x to substitute in this. We guess values for x to substitute in this so that the simplified answer becomes 0. That means we are going to use Converse of the factor theorem to find the factors. The converse of the factor theorem we can use to find factors of polynomial functions in this way. Now, people, suppose this example, I am going to take x squared minus 5x plus 6 as our fx function. Now, I am going to put x equals 2 here. Then we get f2. 2 squared minus 5 into 2 plus 6. Then here we get 10 minus 10. It is 0. f2 0. In that case, people, if f2 is 0, according to the converse of the factor theorem, to get this f2 0, what is the value we substituted for x in the function? X equals 2. Once you bring this 2 to left hand side, we get x minus 2. And this becomes a factor of what is fx. That is a very obvious fact. We can really factorize this. The 2 factors we get are this. You can see obviously this x minus 2 is a factor of this fx that is coming by this way. So therefore, we can guess values for this x and simplify this, put in that value. If we get the answer 0, then thereby we can form one factor. How? Taking that x value, the right hand side value to left hand side, you get the factor. That is the first method, right? Now, second method is this. Second method is, people, we can write this function 2x cubed plus 15x squared plus 6x minus 7. We know already a factor of this x plus 1. That we write first. And this is first degree polynomial. Another second degree polynomial we should have to the right hand side, because the left hand side degree is 3, the right hand side degree should also be 3. Here degree 1 function available, another second degree function should be here. Then only the right hand side sum of the degrees of the functions become 3. So then this is second degree polynomial function. that second degree polynomial function we are going to assume as this way. In the most general form, we can write the second degree polynomial function like this: ax squared plus bx plus c. Now we can find this ABC. Thereafter, we can get know this. This is second degree function that can easily be factorized. Now to find this ABC, people, what we do is we can equate the coefficients. We can equate the coefficients. Right? Why? Because two polynomial functions are available here. No, when two polynomial functions are equal, people, the corresponding coefficients of the same powers of x in the left and right must be equal. Then we can equate x cube coefficients. X cube term is coming to right hand side only by one way. So what is that? When you use this x to multiply this, x into ax squared. It is ax cube, no? What is that? Ax cube. The coefficient is a. Left hand side it is 2. Then 2 equals a. That gives a equals 2. Now this equality, two equal polynomial functions. When two polynomial functions are equal, people, that says at any value of x, both sides are equal. So therefore, we can put x equals 0. When you put x equals 0, we get left hand side -7. Right hand side, this bracket is 1. This is 0. This is 0. We get c. This means c -7. Now, one more thing, that is capital B. We can find capital B either by equating coefficients or putting another value for x on left and right. Then I'll put people this way. I'm going to equate x squared coefficients in the left and right. Left hand side x squared coefficient is 15. To the right hand side, x squared terms are coming in two ways. First way is when we multiply this x, when you use this x to multiply the terms in the second bracket, what do you get? X into bx. Other term we get bx squared. What is the coefficient of x squared? It's b. Second method is, people, once you use this 1 to multiply the terms in the second bracket, 1 into ax squared, we get ax squared, the coefficient is plus a. A is known as 2, put that 2 where here. Then b comes as, people, 13. Then the second factor we know, it is a quadratic factor. That quadratic factor, people, you can very easily factorize. Okay? Yeah. Okay, now we can write it like this. Therefore, we can write that function 2x cubed plus 15x squared plus 6x minus 7 is equal to x plus 1 times a is 2, then 2x squared plus b. B is 13, x plus c. C is minus 7. Now we can factorize this. Then once you factorize this, you get the 3 linear factors. Then factorize this. This way we get the 2 factors, no? Then this is how we write the fx as a product of linear factors. Right, now people ask another one. Read the next part of the question. Okay, the next part is people ask in this way. Hence solve 8a x cube plus 16x squared equals b minus 12x. Hence solve. Right? Our a is 2, b7. A2, B7. Those A and B only people available here. I'll substitute that for the places of A and B. Then what do you get here? A2 means 16x cube plus 60x squared 7 minus 12x. Now take this all the terms to left hand side. 16x cube plus 60x squared plus 12x minus 7 equals 0. This is what we get. I'll keep this equation and start. People are asking to find the solution of this. Solution means people, this is cubic equation. This equation is equal to 0. Then the solution of this means what are the x values? What are the x values for this equation to be 0? Those x values are the solution of this equation. You know, if we have factors of this, like this, suppose we could find 3 factors like this, then equating this each factor to 0, you can find 3 answers for x. Then our first effort should be to factorize this. This is coming under hence part. Hence part means people, the factors of this should be able to find using this. Okay. Let's see how to use this to find the factors of this. Right, now I can take this. Right, taking that, can write since 2x cube plus 15x squared plus 6x minus 7 is equal to x plus 1, 2x minus 1, x plus 7. You know, people here in the left and right, x means any real number. At any value of x, at any real number when you substitute for x, the left hand side and right hand side become equal. Because in the left hand side, expression factor form only, right hand side we have. Then we can put any value for x. Then I am going to put for this x, what? 2x. When x is a real number, multiplying that by 2, the answer is another real number. Since this left and right hand side are equal for any real number, when you put for x 2x, still the left hand side and right hand side must be equal. Right? Now you can write, put in 2x for x on both sides. What do you get? 2 times x is now 2x. 15, 2x squared. 6 into 2x minus 7. On the right hand side also we have people now. X is 2x. 2 times 2x. And 2x plus 7. Here what do you get? 2 to the power 3 is 8 into 2, 16x cubed. 2 squared is 4 into 15, 60 people. X squared. 12x minus 7 is equal to that. 2x plus 1, 4x minus 1, 2x plus 7. This is what we get. Then, what is this really? It is this one, no? Then, the factor form of this right hand side, we can substitute for here. Then you can find the solution of what this. Now you can write now by star. For this one, I can write the right hand side factor form. 2x plus 1, 4x minus 1, 2x plus 7 is equal to 0. Now you can equate each factor to 0 and thereby you can find the solution. This implies what people? 2x plus 1 is equal to 0 or 4x minus 1 is equal to 0 or 2x plus 7 is equal to 0. Then here we get x equals minus half, x equals 1 by 4, x equals minus 7 by 2. This way we get the values. Therefore, the solutions of this one are these three. Okay, fine. Take table 36. Take 36 as the next one. Take question number 36. Right, question number 36, given fx x to the power 4 plus hx cube plus gx squared minus 16x minus 12, where h and g are constants. Given that x plus 1 is a factor of fx, x plus 1 is a factor of fx, mean once we equate this 0, we get x equals minus 1. No? That minus 1, when we substitute at these places of x, the simplified answer should be equal to 0. That means, it means people, if minus 1 is 0, if minus 1 can easily be obtained, put in x equals minus 1 here, and then minus 1 to the power 4 is 1 people. Here minus 1 to the power 3 is minus 1 minus h plus g plus 16 minus 12 is equal to 0. Okay, then here we get g minus h equals 17. Distance is 17 minus 12 is 5 minus 5. First equation. And when fx is divided by x minus 1, the remainder is 24. When fx is divided by x minus 1, remainder is minus 24. What is this result? Once we equate this to 0, we get x equals 1. When we put that x equals 1 on this right hand side, every x, you get something. That is the remainder. That is equal to minus 24. Right? Put that here. Therefore, f1 is minus 24. F1 can easily be obtained putting x equals 1 here. 1 to the power 4 is 1. H into 1 to the power 3. It is h. G 1 squared. G minus 16 minus 12 is equal to minus 24. Then here h plus g we have. Here we get minus 28. Minus 27. Take that right hand side. 27 minus 24 is 3. Right? This is number 2. Now, by simplifying this, we can find h and g. By 1 and 2, we can write this and this, you can cancel down. 2g equals minus 2. Right now, minus h plus h can be cancelled down. 2g equals minus 2. G minus 1. If g is minus 1, put that here, h is 4. We found that. Show that x minus 2 is a factor of fx. In order to show x minus 2 is a factor of fx, you can use people the factor theorem. If x minus 2 is a factor of fx, what should be 0? f2 must be 0. f2 must be 0. Right now, first of all, we write fx. Therefore, fx function you can write, substituting for this h and g. H is 4 for x cube, g minus 1 minus x squared minus 16x minus 12. Then to show x minus 2 is a factor, to show x minus 2 is a factor of this fx, what value we have to subject? What value we have to put for this x? Once we equate this x minus 2 to 0, what is the x value? X is 2. That 2 we have to substitute here. And we have to prove that simplified answer is 0. Then we get f2 equals 0. Then it verifies that x minus 2 is a factor of fx. Put x equals 2. f2 to the power 4, 4 times 2 to the power 3, 16 into minus 12. This is equal to 16, 32, minus 4, minus 32, minus 12. We can cancel down 16 and over there, 16 we have 0. Therefore, x minus 2 is a factor. Of fx. Then we are given x plus 1 is a factor of this fx. Just now we proved x minus 2 is a factor of fx. This fx is 4th degree polynomial function. It already has 2 factors. Then ask me what people x plus fx as product of linear factors, right? Now, this fx, that is this, has two factors, x minus 2, other one x plus 1. Then people, as we proved here, if we can find another two x values, when you substitute them via here, the right hand side becomes 0. The rest two factors can easily be found. Then we will try to find at least one x value which brings this right hand side 0. Then we can obtain another one factor. Then another one more we need to find. So now, when we put people another x value, at what x value this becomes 0? Just try that. What x value this becomes 0? Decide values of x. Yeah, can you give me some values for x which brings this right hand side 0? When you put x minus 2, people, see here. When x equals minus 2, what do you get there? F minus 2. Minus 2 to the power 4 plus 4 times minus 2 to the power 3 minus 2 to the power 2 minus 16 into minus 2 minus 12. Simplify this. What do you get here? Plus 16. Here minus 8 into 4 minus 32. Here plus 4 and minus 4 and plus 32 minus 12. These two you can cancel down. Minus 4 minus 12 minus 16 plus 16 also cancel down. If minus 2 also 0, people. Then we can find another factor. What is that? Once we bring this minus 2 to this side, we get x plus 2. Therefore, x plus 2 is a factor of fx. Then there are three factors. Another one more factor of this fx we need to find. Because three factors we have, this is 4th degree polynomial function. Then another one factor of 1st degree available for this fx. Then you can write it like this. We can write this fx now. X to the power 4, 4x cubed minus x squared minus 16x minus 12. First fact is given x plus 1. The other factor we proved x minus 2. And another factor we found as x plus 2. Right? Now here degree 1, degree 1, degree 1. 1 plus 1 is degree 3. Left hand side degree 4. Then the right hand side degree to be 4, another one factor should be there. Its degree should be 1. That means the next factor should be the linear factor. We can write it as ax plus b. Then we can find a and b. Right, now you can find this a. How, people? Equating coefficients of x to the power 4. Left hand side it is 1. Right hand side, the x to the power 4 term is coming how? Multiplying, taking from every bracket this x term. When you multiply, we get to the right hand side the highest power of x as x to the power 4. Right, people? Always remember, if we need to take the highest power term from this right hand side, then you have to multiply, taking from every bracket the highest power term and multiplying. Then here x, 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 ax, then ax4 coming. Coefficient going to be people a, then a equals 1. Now to find this b, put x equals 0. Then we get left hand side minus 12. Right hand side, here 1, second bracket minus 2, third bracket 2, fourth is b. Then we get here minus, we can cancel down 12 for b, b is 3. Now people, we can write the factors. How? Write this again, substitute in a, 1 and b, 3. Then I am going to write that we are here. x4 plus 4x cubed minus x squared minus 16x minus 12 equals x plus 1 x minus 2 x plus 2, a is 1, then next b is 3. This is how people we take that. But we will now take the next one as number 37. Take number 37. Right, we are given gx. The function gx given as ax4 minus 2x cubed minus 4x plus b. They be real numbers. X plus 1 is a factor of gx. X plus 1 is a factor of gx mean what people? G minus 1, 0. How to take this g minus 1? Since x plus 1 is a factor, equate that to 0, x is minus 1. This value only we have to put for every x. Then we get g minus 1. That should be 0 according to factor theorem, right? Then we can obtain one equation by that. G minus 1 is 0. G minus 1 means substitute for this x minus 1 to the power 4 is 1. 1 into a is a. And here minus 1 to the power 3 is minus 1. Then plus 2 and plus 4 plus b equals 0. Then we get a plus b is equal to minus 6. When gx is divided by x plus 2, the remainder is 48. Remainder 48. That means when it is divided by x plus 2 means the x value is minus 2. When we put x value minus 2, we get g minus 2. It is the remainder according to remainder theorem. Since that remainder is 48, this should be equal to 48. G minus 2. Right, now put x equals minus 2. Minus 2 to the power 4 is 16 a, and here minus 2 to the power 3 is minus 8, then plus 16 and plus 8 plus b is equal to 48. Put x equals minus 2, 16 a plus 16 plus 8 plus b. And here we get 16a plus b. Here we get 24. Take the right hand side. Then we get another 24. Then 2 minus 1. C and b you can cancel down. 15a. Here 30. A is 2. When a is 2, b is minus 8. b is minus 8. Now gx function you can write. Therefore gx is 2x4 minus 2x cube minus 4x plus b minus 8. Separate gx into linear factors. One factor we know, that is x plus 1. That's given, no? Now the 3 more linear factors that should have, the gx should have. Therefore, at another 3 values of x, the gx function must be 0. If we can find those x values, very easily we can find the factors of this gx, and hence we can write the gx as the product of linear factors. Separate gx into linear factors and hence find all the roots. We will now try to find the rest roots of this gx. There are 2 ways. First way is by using the converse of the factor theorem. Guess value for x, substitute that in the function, simplify. If we get 0, then by that we can find one factor. Like that, using the trial and error method, find x values which brings the right hand side 0 of gx. Thereby you can find factors. Understood? Okay, all right. Now find the factors. Right. Now when you put x equals to, what do you get? G2. 2 times 2 to the power 4 minus 2 times 2 to the power 3 minus 4 into 2 minus 8. See here? Here 16 into 32. Here 8 into 16. 8, 8. This is also 32. 32 minus 32. This is 0. G2 is 0. Therefore, x minus 2 is a factor of gx. Now we have 2 factors. One is we know initially x plus 1, now x minus 2. People, now this is 4th degree polynomial function. No? So therefore, if it has more factors as linear factors, then there should be another 2 x values which brings this right hand side of gx with 0. Right. Try that one. If not, people, that way we can't find the factors. Then we use the next method like this. Then this gx, people, we can write 2x4 minus 2x cube minus 4x minus 8. Right. It has now 2 factors. One is x plus 1. Other one is x minus 2. Degree 4, here degree 1, degree 1, degree 2. Then the next factor, if it has only one factor as the 3rd factor, that should definitely be 2nd degree polynomial. Then only there are degree 2, here 1, 3, here 1, 4. The right hand side degree will be 4, which is equal to left hand side degree 4. Right. So then I am taking the 3rd factor is quadratic factor, 2nd degree function. So then I write it as this way: alpha x squared plus beta x plus gamma. This way I take as the 3rd factor. After finding alpha, beta, gamma, we can find the 3rd factor. It is a quadratic one. Then we can very easily factorize that into 2 linear factors if it has linear factors. Then equating coefficients of x power 4, you know, to the right hand side, the highest power of x is forming, taken from every bracket, the highest power of x and multiply. Then we get highest power term of x on the right hand side. X squared into alpha x squared means alpha x4 coming. Then coefficient is alpha on the right hand side. That is in the left hand side, this alpha 2. Put x0 here minus 8. Right hand side, here 1, here minus 2, and there gamma. X0 minus 2 gamma, then gamma is 4. Another one more, that is beta. Put another x value, v value. Put x equals 1. What do you get here? Here 2, here minus 2, here 12, minus 12. This is 2, this is minus 1, alpha plus beta plus gamma. Here we get 6, no? Alpha people 2, beta unknown, gamma 4. Here 6 and here 6, beta 0. Beta 0. Then third factor is people 2x squared plus 4. Right? Then we can write gx. Two x4 minus 2x cubed minus 4x minus 8. This is our gx. Gx can then be written as x plus 1, x minus 2. And people alpha, it's 2, beta 0, gamma 4. This way we have. Then these 2 we can take out. Then we get x squared plus 2. Then people know 4 linear factors for this gx. Only 2 linear factors, and the third factor is second degree factor. So therefore, if we furthermore try to find x values here to find the next factors as linear factors, unsuccessful effort, meaningless effort there. In that case, people, this method is the way of finding the third factor. Asking to write in the question, separate gx into linear factors and hence find all the roots of gx equals 0. There we get a misleading idea. There we get the idea that gx has all linear factors, but there are 2. Right. Now gx equals 0. This is our gx, huh? This is our gx. The gx is this. Right? Okay. Now gx equals 0. Its roots we have to find. For this gx, now I can put this 2 times x plus 1, x minus 2, x squared plus 2 is equal to 0. People, you know, for any value of x, this is not equal to 0. Therefore, why people? You know, here x squared is positive or 0. If this is positive, this bracket is positive. If x is 0, still there is a 2. Then for this product to be 0, people, either this x plus 1 or x minus 2 must be equal to 0. So then this gives us x plus 1 equals 0 or x minus 2 equals 0. This implies x is minus 1, x is 2. They are the solutions of gx equals 0. Now ask another one more. By writing x plus 1, x minus 2, that is this. X plus 1, x minus 2 equals x times x minus 1 plus mu. Show that when gx is divided by x cube plus 2x, the remainder is this answer. Okay, we'll come to that now. Right. Here now, x plus 1, x minus 2. Asking to write it, people, x times x minus 1 plus mu. Okay. Now we can put x equals 0 because this equality is not an equation. Two equal polynomial functions. When I put x equals 0, this bracket is 1, this bracket is minus 2, 1 into minus 2 is minus 2. On the right hand side, when you put x 0, this is 0, then we get mu. Minus 2 equals mu, then mu equals minus 2. Okay. Now I can come to this gx place. Right. Now gx you can write 2 times x plus 1, x minus 2, x squared plus 2. Then I can write this one, people, 2 times this x plus 1, x minus 2 only. We can write this one now. With 2 times, open a bracket, x times x minus 1 plus mu. Mu is minus 2. X squared plus 2. Okay. What is asking to prove there? Show that when gx is divided by x cube plus 2x, the remainder is this. All right. So then we multiply like this, people. We remove the bracket by multiplying this. First this, second this, meantime we multiply by 2. Gx is equal to 2 times x minus 1 times x squared plus 2. This and this when you multiply, minus 4 x squared plus 2. Now, by this x, people, you can multiply this bracket. Gx times gx equals 2 times x minus 1. When you multiply by this x, we get x cube plus 2x coming. I can write this as plus minus 4 x squared plus 2 within the bracket like this. Okay. Now we will, if I consider this as a separate function, after first time this as a separate function, really here we have what, people? Here we have algorithm of division. Now If we consider this as the divisor and this as the quotient, then this can be considered as people the remainder. This is a dividend function. Then here what we have is people algorithm of division. This says when gx is divided by this function, the remainder is this. Then no need to write that in words, just you can write like this. Hence, when gx is divided by this x cube plus 2x, the remainder is that. Then you can write. Hence, when gx is divided by x cube plus 2x, the remainder is minus 4 times x squared plus 2. This is how we take that answer. Right. Right, we will now take question number 38 as the next. Number 38. Number 38. Right. Now it says, let fx be a polynomial of degree greater than 2. And let p and q be distinct real numbers. Applying the remainder theorem twice, show that the remainder when fx is divided by x minus p into x minus q is this answer. This is the first part. Remainder theorem should be applied twice to get this answer. Okay, now this is how we apply remainder theorem. When fx, right, first we divide by this x minus p. Right? Then we get a quotient. I'm assuming that quotient as hx. Quotient is hx. And we get a remainder here. What are the remainder, people? Remainder is fp, no? Fp. How to get this fp? By the remainder theorem. How? Divide this x minus p, equate this to 0, we get x equals p. That x value p we have to put where? Here. We get fp. That is the remainder according to remainder theorem. Then here by using algorithm of division, we can write a relation fx equals this multiplied by this plus this fp. Now by algorithm of division, we can write fx is equal to x minus p into hx plus fp. This is number 1. Secondly, people, this resulting quotient I am going to divide by x minus q. That resulting quotient hx, no? hx function we divide by x minus q, right? Then we get a quotient. I am going to take that as sx, and we must get a remainder. What is that remainder? It is hq. It is hq. Okay. Now, right. Okay, no, right. Now we can write people again by using the algorithm of division. This hx function, this hx function, this one, this into this, x minus q into sx plus hq, number 2. Now using this, you can write people. The required answer, right? Take 2-3 minutes and try to get this answer. Got it? Okay, now we can do like this. Here we have hx. For this hx, I am going to substitute by number 2 this hx. Substituting for hx in number 1 by number 2. What do you get there? Fx is equal to x minus p, open a bracket, hx. To write hx, I leave this bracket, and then fp. Here I must write this hx, that means this x minus q is 6 plus hq. Then we can multiply, we can remove the bracket, x minus p, x minus q is 6, and x minus p hq plus fp, right? Then you can consider fx as the dividend, x minus p, x minus q as the divisor. This is the quotient. This is the dividend, divisor, quotient. Then this whole should be remainder. That means when fx is divided by this product, the remainder is this. Then you can write, therefore, when fx is divided by x minus p, x minus q, the remainder is this. The remainder is x minus p into HQ plus FP. But this is not the answer. Ask in the show. The answer doesn't contain HQ. We have to find HQ. How to find HQ? HQ can easily be found, people. Putting in number 1, for this x, when you put q, we get FQ. From here, we get HQ. Right? Now, y, number 1, put in x equals q. What do you get? FQ here, q minus p, HQ. Here we don't have etc to put that q, FP. HQ can be subject. Take this side and divide by q minus p. Therefore, HQ we can subject. It is FQ minus FP. Take this to this side. FQ minus FP divided by q minus p. Now that HQ, I am going to substitute where here. Therefore, the remainder. Now you can write x minus p times HQ is this FQ minus FP divided by q minus p plus FP. Right? This should be the answer. FQ minus FP divided by q minus p, x minus p, correct? No? Plus FP. This is how we take that answer. Right. Okay. Read the next part. Read the next part of the question, people. And now given this way, we are given a gx function. Gx function given as x cube plus ax squared plus bx plus 1. They be real numbers. It is given that the remainder when gx is divided by x minus 2. Gx divided by x minus 2, the remainder g2 is twice the remainder when it is divided by x minus 1. This is equal to 3 times. This is equal to 3 times when it is divided by x minus 1. when gx is divided by x minus 1, the remainder is g1. g1 multiplied by 3 is g2. That's what it says. g2 we can write, substitute x equals 2 at these places. Then 2 to the power 3, 8, 4a, 2b plus 1 is equal to 3 times g1 x equals 1 to the power 3. That means 1, a plus b plus 1. By simplifying this, you get one equation, a minus b equals minus 3. Number 1, no? Here 3a, take this side a, 3b minus b. Here 1, 2, 6, and here 9, then minus 3. The remainder when gx is divided by x minus 1, x minus 2 is kx plus 5. Right. Kx plus 5. Right. The next one, how to use the next data to obtain another two equations? There are three unknowns, no? A, B, and K. To find three unknowns, people, we should have three equations. Right. Now, for that you can follow this previous result. Now this says when fx is divided by x minus p, x minus q, the remainder is this figure. Remainder is this figure. That's the theory part. Right. Now we are given gx. Instead of this fx, now we have gx. Now gx is divided by x minus 1, x minus 2. Then the remainder given kx plus 5. Okay, this is what we are given here. But we have proved something here like this. When a function fx is divided by x minus p, x minus q, the remainder we can write like this. The same theory here we proved can be applied to write the remainder when this gx is divided by x minus 1, x minus 2. Only thing here you have to do is, by comparing with this, determine first p and q. And for the place of fx, we have now gx. Then those values, when we substitute in this, we can find the remainder in another way. When this gx is divided by x minus 1 and x minus 2. That remainder and this given remainder kx plus 5 should be the same. Therefore, that two polynomial functions we get as the remainder when gx is divided by x minus 1, x minus 2 should be equal. When two polynomial functions are equal, people, you can equate the corresponding coefficients of the same powers. Thereby, another two equations can be drawn involving a, b, and k. Then with this equation, three equations. By solving them, people, we can find this a, b, and k. Again, try this question. I'll give 2-3 minutes. Hurry up. Right, people? Yeah, we'll see. You can now write. Let's find the remainder when gx is divided by x minus 1 into x minus 2 by using the result proved above. Compare people this and this P1 Q2. Right. Then the function fx, here now we have gx. Gx is this. Okay. Then tell me the result. This is the remainder. X minus p, p is 1. X minus 1. Here f means g, gq. Gq is 2, g2 minus gp, p is 1, no, g1 divided by q minus p, 2 minus 1 plus fp means that should be gp, p is 1, g1. This is the remainder, people, according to this part proved. But we are given in the question the remainder is kx plus 5. Therefore, this should be equal to kx plus 5. Right. Now, substitute for g2. Put x equals 2 here, g1 here, and g1 here. Then the left hand side will be first degree polynomial in x. That is equal to this. Then equate the coefficients of x to the power 1 on both sides and constants on both sides. Thereby another 2 equations we get. Solving the 3 equations, you can find what this a, b, and k. That's method, people. Take that. X minus 1, g2. Put 2 here. 2 to the power 3, 8. And 4a. And 2b plus 1, g2 minus g1. X equals 1. There are 1, here 1, 2, a plus b. Divided by 2 minus 1 is 1 plus g1. It is 2 plus a plus b. This is equal to kx plus 5. And here x minus 1. Right. 8 plus 1, 9. 9 minus 2 is 7. 4a minus a, 3a. 2b minus b, it's b. Is equal to kx plus 5. Now we can simplify furthermore, people here. Here we can write 3a plus b plus 7 into x minus 1. A plus b plus 2 is equal to kx plus 5. We can multiply by this x, this 3a plus b plus 7 times 6. This and this minus 3a minus b minus 7 plus a plus b plus 2 kx plus 5. Then equate the coefficients of x. Here x coefficient is 3a plus b plus 7 is equal to here k. Second equation number 2. And this is a constant that should be equal to this 5. What do you get there? Minus 3a plus a is minus 2a. Minus b plus b you can cancel down. Minus 7 plus 2 minus 5. Equal to 5. Equation coefficients of x power 0. Right now? From here minus 2a is 10, a is minus 5. If a is minus 5, put that here by 1. Minus 5 also bring to this side. 5 minus 3 is 2. Minus b is 2, b minus 2. Now by number 2, you can take k. K equals, here we get minus 15, minus 2, minus 17, plus 7 means minus 10. K minus 10. This is how we take that values. It's a good question, really. Right. But as the next question people take, question number 44. Question number 44. Question number 44. Right. I'll give you for a few minutes, people. Start this 44. Right. Question number 44. Yun. Let qx x squared alpha x plus 4 second degree polynomial function hx x cube minus beta x squared plus x plus 11. Right. Qx given x squared minus alpha x plus 4. Hx x cube minus beta x squared plus 6 plus 11. When qx is divided by x minus 1, the remainder is 2. Qx divided by x minus 1. Qx divided by x minus 1. The remainder is 2. Then according to remainder theorem, the remainder is q1. It only given as 2. Then q1 is 2. According to remainder theorem, when qx is divided by x minus 1, the remainder is q1. It is 2. Q1 2. Q1 can be found, people, putting x equals 1 here. 1 squared minus alpha into 1 plus 4 is equal to 2. Here we get 5. Take this 2 to this side, minus 2 equals alpha. Alpha is 3. Alpha is 3, right? Hx is divided by h plus 1, right? Hx is divided by x plus 1. What is the remainder according to remainder theorem? H minus 1. Hx is divided by x plus 1, the remainder is 7. Okay. Then h minus 1 you can simplify here, put x equals minus 1 here. This way. Here minus 1, here minus beta, minus 1 plus 11 is 10 equals 7. Beta is equal to 2. Beta 2. Find alpha and beta. For these values of alpha and beta, verify that hx is this R. Now we can write people qx and hx. Therefore, qx we can write substituting for alpha 3, x squared minus alpha is 3, 3x plus 4. And hx we can write x cube minus beta, beta is 2, 2x squared plus x plus 11, this way. Right. Now verify that hx is equal to x plus 1 into qx plus 7. Right. First of all, we'll see starting from the right hand side, x plus 1 times qx plus 7. We'll substitute for this qx from here and keep simplifying this. We'll take the answer of this hx. Then that is verified. Okay. Then we get there x plus 1 into qx, x squared minus 3x plus 4, and here 7. Now simplify this, remove the bracket. What do you get? By x we get x cube, and here we get this and this minus 3x squared, this and this plus x squared minus 2x squared. Now x terms, here 4x, here 3x, it is 6, here 4, here 7, 11. This is what we get. X cube minus 2x plus x plus 11 means this. It is hx. Therefore, x plus 1 into qx plus 7 is equal to hx. We get that way. Right, next one, people asking express qx in the form qx. Yes, this no. Asking to write qx in the form x minus 2 x plus lambda plus mu. Right. Now I can put for this qx this x squared minus 3x plus 4 is equal to x minus 2 x plus lambda plus mu. We have determined this lambda and mu, people. We have determined this lambda and mu. Now here we have two equal polynomial functions. We can put any value for x on both sides. Put x equals 2. 2 minus 2, this is 0. Then this product is 0. On the right hand side we have mu. When you put x equals 2 here, 2 squared 4, 4 plus 4 is 8, here minus 6, then 2. We get 2 equals mu means mu 2. Now lambda can be found, people. Put x equals 0. This is 0. Then we get 4 here. Here minus 2 times lambda plus mu. Mu is 2. Right. Take this side, 2 lambda minus 2. Lambda is minus 1. Then we have qx. Therefore, we can write qx is equal to x minus 2 times x plus lambda, lambda minus 1, x minus 1 plus mu, mu is 2. We wrote that qx in that asking form. Now asking this, hence show that when hx is divided by x plus 1, x minus 2, the remainder is 2x plus 9. Hence, here we have people hx. We start from there. Hx equals x plus 1 into qx plus 7. Hx equals x plus 1 qx is this now. X minus 2, x minus 1 plus 2 plus 7. Now I multiply this way. By this I multiply this term and this term. Then we get hx x plus 1 x minus 2 x minus 1 2 times x plus 1 plus 7. Then we can write hx x plus 1 x minus 2. I take like this, and x minus 1. Here 2x, 2 into 1 is 2 plus 7 is 9. Right? Now you can consider this as your dividend function. This can be considered as the divisor function. This function is the quotient function. This is a remainder function. Then you can say when hx is divided by this divisor, remainder is this. That you have tried in words. What people? Therefore, when hx is divided by x plus 1 x minus 2, when hx is divided by x plus 1 x minus 2, the remainder is this. The remainder is this. 2x plus 9. Right, we will now take question number 46, second part first. Question number 46, part 2. Question number 46, part 2. 46, part 2. Read that question number. 46, part 2. Right. 46, part 2. You are given hx. hx. It is x cube plus ax square plus bx plus c. ABC real numbers. It is given that x squared minus 1 is a factor of hx. X squared minus 1 is a factor of hx. Yeah. That means we can write hx as x squared minus 1 into another function fx. This way we can write. People, that way, when x squared minus 1 is a factor of hx, we can write this hx as the product of x squared minus 1 into fx. That's correct, no? 3 is a factor of 12, then 12 we can write as 3 into 4, like that. Then here, if I put x equals 1, what you get is here h1 equals 1 squared minus 1 is 0. In whatever this f1, since this is 0, this is 0, people, right? By this, you can understand x minus 1 is a factor because h1 equals 0 means x minus 1 is a factor. Okay. People, actually, no need to use this way to understand that x minus 1 is a factor of this hx. You can write this hx, right? This way, x minus 1, this x squared minus 1 we can factorize this way. X plus 1 and fx we can write like this. Then obviously you can see x minus 1 is a factor of hx, as well as x plus 1 also a factor of this hx. Okay. But people here, by using this h1 equals 0, here there are 3 unknowns to find in hx. Then h1 equals 0. We got like that. Like that, people, when I put x equals minus 1, what do you get? H minus 1. That also here minus 1 squared minus 1 into f minus 1. Minus 1 squared is 1. 1 minus 1 is 0. The product is 0. Then h minus 1 also 0. This data and this data are very important to obtain equations involving ABC. Right now, h1 0 mean h1 equals 0 mean put x equals 1 here. 1 cube a into 1 squared b into 1 plus c equals, this is h1, it should be 0. And here we get a plus b plus c, take this right hand side minus 1. Okay. H minus 1, put here minus 1. This implies minus 1 cube a minus 1 squared b minus 1 plus c, that is 0. And here a minus b plus c, a minus 1 take right hand side plus 1, number 2. 2 equations we obtained. Asking to show people b as minus 1. Take 1 minus 2. A plus C can be cancelled down. B minus B is minus B minus B plus B, 2B coming to the left hand side. Right hand side minus 2, minus 1, minus 2. B is minus 1. We get the answer for B as minus 1. Next one, people, given that when hx is divided by x squared minus 2x, the remainder is 5x plus k. hx is divided by x squared minus 2x. When hx is divided by x squared minus 2x, the remainder is r. I'm going to assume when hx is divided by x squared minus 2x, people, I'm going to assume the quotient as gx and the remainder given as 5x plus k. This way I can write. We are given when hx is divided by x squared minus 2x, the remainder is 5x plus k. Now I am going to assume when hx is divided by x squared minus 2x, the quotient is gx and remainder is this given 5x plus k. Now for this hx, people, I can substitute, right, this x cube plus ax squared plus bx plus c, x squared minus 2x times gx plus 5x plus k. Okay. Now here, people, now how many unknowns are there? A, B, C and K. 4 unknowns, but B is known. Another 3 more unknowns available there. Right. Now I am going to put x equals 0 here in both sides. This is 0, this is 0, this is 0. Left hand side C. When you put x equals 0, this bracket is 0, then this product is 0. And x equals 0 brings right hand side k. Then C equals k. Okay. Now I can put x equals 2. People, why can't we put any value for x in this relation? We have to always select a value for x which brings this factor 0. Then this gx is unknown function, people. If this unknown function gx comes into our account in the answers, since it is an unknown function, all the answers will be coming again with another unknown function. Then we can't find that a, b, c and k. So therefore we have to make sure to put x values so that in the equations involving a, b, c, the function involving gx will not be coming. Okay. Then now, people, when I put x equals 2 here 2 squared 4 minus 2 into 2, 4, 4 minus 4, this is 0, this product is 0. Then there, when I put x equals 2, 10 plus k coming. Then here 2 to the power 3, 8. Here 2 squared 4a plus 2b plus c. People, we know the value of b minus 1, right? Then we get 8 plus 4a. Here b minus 1 means minus 2 plus c equals 10 plus k. What is asking there, people? Find the value of k and show that hx can be written as r. Then a, b, c, k, all values we need to find. Right now, I can do it like this. C equals k. then 8 minus 2, 6 plus 4a. For this c, I can put k. 10 plus k. These two we can cancel down. Then we get 4a. Take this right hand side. 10 minus 6 is 4. Then we get a as 1. A as 1. If a is 1, put in by 1, we get people a1, b minus 1, and c equals minus 1. These two we can cancel down. C is minus 1. If c is minus 1, c is equal to k. Therefore, k is minus 1. Then these 4 unknowns we found. Now, what is the question next? Show that hx can be written as this way. Now we'll write hx, substitute for this a, b, and c. Write hx. Therefore, hx. Value of a is 1, b minus 1, c also minus 1. Then you can write hx, people. Take x squared out from these first two terms, then x plus 1 come in. Take minus 1 out from the last two terms, x plus 1 come in. Take this x plus 1 out. Then we get x squared minus 1. The factors. I'm asking to write this way. You can factorize this. X squared minus 1 as x plus 1, x minus 1. X plus 1 perfect squared into x minus 1. Now you can, compare this hx with the given answer, x minus lambda perfect squared and x minus mu, no? In the place of lambda, what do we have? Here minus lambda equals 1, lambda is minus 1. Mu is 1 r. In the asking form we have shown now, right? Right. Take 46 part 1. Take 46 part 1. For 6 part 1. This let fxy bivariable function. A function with two variables are called as bivariable functions. Fxy 2x squared plus lambda xy plus 3y squared minus 5y minus 2. Find lambda a, b, c, p, q, and r such that this way fxy equals this. Right. We'll come to that. Right. Fxy given 2x squared plus lambda xy plus 3y squared minus 5y minus 2. Asking to write this one as a product of ax plus by plus c, px plus qy plus r. Then we write this way: 2x squared plus lambda xy plus 3y squared minus 5y minus 2 is equal to ax plus by plus c times px plus qy plus r. Right, people, here there are 7 unknowns: a, b, c, p, q, r. There are 6 with this lambda 7. Right. Here also the equality, left hand side and right hand side are equal, mean people, for any value of x and y, both sides are equal. So therefore we can substitute any value for x and y in left and right. Now I am going to put x equals 0. Then this is 0, this is 0. Then we get 3y squared minus 5y minus 2 is equal to x equals 0 brings here by plus c, qy plus r. Now straight away we can people determine these 4 unknowns by factorizing this left hand side. Yeah, this is a quadratic expression in y. Factorize that. Here we can write 3y y. We can write here people minus 2 plus 1. The factors. You get minus 6y plus y minus 5y, and here minus 2. Then you can compare both sides. Comparing both sides. Right? Now we can consider this bracket on the right hand side as this, right? Comparing. Then here y coefficient b, here it's 3. Therefore 3 equals b, b equals 3. C equals 1. Then you might think, what if this 2 interchange? Then this b and c will be different, no? You feel like that, but people, that will not anyway be affected to the final answer. Even though interchange in this 2 product, these 2 factors, right? If you determine this way, correct people. And this and this, here 1, here q, q is 1, and r is minus 2. 4 unknowns out of 7 we found. Now in this we put y0 secondly. We put y0. Okay. Now take this as star, put x equals 0 in star. Now put y0 people. Right? Put y0 in star. Then once you put y0 people, here we have 2x squared. This is 0, this is 0, this is 0, minus 2. Right? The y0 brings ax plus c here. Px plus r. Now we know people values of these. C we know. Ax plus 1. R we know. Px minus 2. Here 2x squared minus 2. Now in the second location, people, second location, as we did here, don't go to compare. Second location, we have to equate the coefficients on both sides, right? Equating coefficients on both sides. Equating coefficients on both sides. What do you get here? A into P is the x coefficient on the right hand side, that is in the left hand side 2. AP is 2, number 1. And people, constants are already equal on both sides. The next one, therefore, x coefficients. Ax into minus 2, coefficient minus 2a. This is x squared coefficient, x coefficient, people. Here, a into 2 minus 2a. This into this plus p. But left hand side, we don't have x. That means x coefficient is 0. Then here we get p plus 2a, number 2. Now this p we can put where here? By 1 and 2. A times p. P is 2a is equal to this and this you can cancel down, we get 1. A squared equals 1, then a will be plus or minus 1. There are two answers for a, plus or minus 1. We don't know which one is correct. Now when a plus or minus 1, then p has two answers. When we take a is 1 plus 1, putting that here, we get p 2 into 1, 2, p2. When a equals minus 1, here p is minus 2. There are two sets of values for a and p, and one value for this. Now, another one thing is there. What is that? People, we have to find lambda. Yeah, to find the lambda, what we do is this. In the left and right, we equate the coefficients of xy product terms. Xy product terms. We equate the coefficients of xy product terms. Okay, right. Now we can write that. Equating coefficients of xy product terms. Equating the coefficients of xy terms. People, left hand side it is lambda. Right hand side xy product term. What do you get? Here ax term, and here qy. What do you get? aq. Another one, bp. Okay, ap plus bq. There are two sets of values, a and p. Therefore, people, lambda is an unknown. In some questions, we will be given this lambda. Then to satisfy this left and right to be equal, in those questions, people, out of these two sets of values, only one set of value will be true. By putting them here, if the lambda is known, we can select the correct set of values from that. But in this case, lambda is an unknown. So therefore, both sets of values we have to select. Okay. And then lambda can be found subject to first result when a equals 1, p equals 2. What is lambda? A1 and Q1. Then here 1, B, B3, P2, B3, P2, then 6, then lambda 7. One value of lambda is 7. Secondly, when A minus 1, P minus 2. What is lambda? A minus 1, Q 1 minus 1. B is 3, P is minus 2, minus 6, lambda minus 7. Then people, there are two sets of values for A, B, C, P, Q, R and lambda. Two sets of values. What are the values? Right. And then you can write there exist two sets of values. Write down. Therefore, there exist two sets of values. Therefore, there exist two sets of values. What are the values? B3, C1, Q1, R minus 2 with these three values. A1, P2, lambda 7. Next one with these values, what? A minus 1, P minus 2, lambda minus 7. This is how people we find that values. Okay. And people take the next question is (45) part 2. 45 part 2. (45) part 2. 45 part 2. Right. Question number 45 part 2. A gx given, people. A function gx given. X cube plus px squared plus qx plus 1. PQ are real numbers. When gx is divided by x minus 1, x plus 2, the remainder is 3x plus 2. Right. This gx, x cubed plus px squared plus qx plus 1. No. We are given when this is divided by x minus 1, x plus 2. The remainder is 3x plus 2. I'm going to assume the quotient has fx. Remainder is 3x plus 2. Then people asking what? Show that the remainder when gx is divided by x minus 1 is 5. The remainder when gx is divided by x minus 1 is 5. Right. So I'll write people here gx. Then when this gx is divided by x minus 1, we have to show the remainder as 5. That means if we can show g1 equals 5, g1 equals 5 people, right? Then that is when gx is divided by x minus 1, remainder is 5. Okay? G1 we get very easily. Right? People, now when I put directly x equals 1, okay, this will be 0. When you put x equals 1, 3 into 1 is 3 plus 2 is 5, g1 5 coming. I can remember this was a past paper question. In that question, they are mentioned without direct substitution. Without direct substituting, find the remainder. When gx is divided by x minus 1, 5. So then I am going to use that method. Here I can write people gx is equal to x minus 1, x plus 2, fx. Here I can write this one like this, 3x minus 3 plus 5. Correct, no? Minus 3 plus 5 is plus 2, this is coming. If we directly put x equals 1, really g1 will be equal to 5, the answer is coming suddenly. But in this question, that kind of answer is not expecting. I think they expect like this. It is not distinguished clearly whether to put x equals 1 or this way in this question. But there was a past paper some like that. If directly substituting x equals 1, getting the answer g1 as 5, no marks. Okay. Now here see how take is gx. X minus 1, x plus 2, fx, take here 3 out, x minus 1 plus 5. Here we have x minus 1, here we have x minus 1. Take that x minus 1 out. Once you take that x minus 1 out, within bracket you can write here x plus 2 fx. Here once you take this x minus 1 out, we get 3 here, then plus 5 only. Now you can take this as your divisor. This you can take as your quotient. Then this should be what your remainder. This is the dividend function. This says us people, when gx is divided by x minus 1, remainder is 5 according to the algorithm of division. Now you can write, therefore, when gx is divided by x minus 1, the remainder is 5. The remainder is 5. Okay. Like that, x plus 2, it is minus 4. In the same way, people, you can arrange that, x plus 2. Right. Right. Now, second case we can take gx is equal to x minus 1, x plus 2 into fx 3x plus 5. Right. Now we have to write that right hand side remainder in terms of x plus 2 terms. And I can write this one 3x plus 6 minus 1. 6 minus 1, 5 coming. You can take this 3 out. Take this 3 out. 6 plus 2 minus 1. Then you can take x plus 2 out from the right hand side. Then here we have x minus 1 into fx plus 3 minus 1. Then we can very clearly see when gx is divided by x plus 2, the remainder is minus 1. I just asking minus 4, no? I have made a mistake. Plus 2, no? This is plus 2, no? 3x plus 2. Then people here, we have to subtract 4. Here, 3x plus 2, really, I wrote instead of that 2, 5. Then correct, no? Then we can write, therefore, when gx is divided by x plus 2, the remainder is minus 4. Okay, now we got that. Find the values of p and q and show that x plus 1 is a factor of gx. Right, ask him to find the values of p and q. Right. Now we know here g1 is 5. G1 5. Now we can use this because we have proved that. And the other one is people g minus 2. When this gx is divided by x plus 2, remainder is minus 4, no? Then taking this sign, this is to 0, then x is minus 2, put that here. G minus 2 is minus 4. You can use these two data, right? Right. G1 5, then put x equals 1 here. 1 cube, p into 1 squared, q into 1 plus 1. It is G1, it is equal to 5. Here p plus q. Here 1, 2, take that right hand side. 3. Number 1. Put minus 2, here minus 8. and 4p minus 2q plus 1 is equal to minus 4. P minus 2q minus 8 plus or minus 7, 3. This is number 2, people. By solving this 1 and 2, we can find P and Q. 1 we multiplied by 2 and add with 3, add with 2. 2p, 2q will cancel off. Here 6p coming. Here 6 plus 3, 9. P we get 3 by 2, no? Is it correct? We multiply 1 by 2, 2p and 4p, then 6p coming, 2q minus 2q. 6 plus 3, 9. P is this much. Then Q, also 3 by 2. And therefore, we can write Gx. Therefore, Gx we can write. Gx is x cube plus P is 3 by 2 x squared. Q also 3 by 2 x plus 1. This is our Gx. Now we have to show people x plus 1 is a factor of Gx. X plus 1 is a factor of Gx. If x plus 1 is a factor of Gx, definitely when you put x equals minus 1 in the function Gx, the G function must be 0. Let's see, put x equals minus 1. We get G minus 1. Minus 1 cubed. 3 by 2 minus 1 squared. 3 by 2 minus 1. Right? And plus 1. Here, people, we get minus 1. Here, plus 1 into 3 by 2 is 3 by 2. Here, plus and minus minus 3 by 2. Here, plus 1. You can cancel down this 2, cancel down this 2. This is 0. G minus 1, 0 means, people, when you take this minus 1 this side, we get x plus 1. No, x plus 1 is the factor of Gx. Hence, x plus 1 is a factor of Gx. Right, people? This is how we take that answer.